Sir, can you hear me? Hello, Shankar sir. Sir, കേൾക്കാൻ പറ്റുന്നുണ്ട്? Yes, sir. Yes, sir. Yes, sir. So can we start?
Yeah.
Yes, sir. Okay. So welcome everyone to day 2 of the Curtain Raiser webinar series in connection with Civilianz Maze 2.0. So today we have with us the very respected Padmashree architect, Dr. G. Shankar, to talk about sustainable building construction. So before beginning, I would like to speak a few words about Dr. Shankar. So Dr. Shankar is an well-known architect from Kerala. He advocates the use of locally available materials, sustainability, eco-friendliness, and cost-effectiveness. He founded the Habitat Technology Group in Thiruvananthapuram in 1987, and as of 2012, he serves on a number of boards. He did his architecture studies from College of Engineering Trivandrum and later did MS from Birmingham School of Architecture, UK, and postgraduate diploma in journalism. He has also won 3 national awards for green architecture, slum resettlement, and eco-city design. His attitude to green architecture has gained him a reputation as the people's architect. Dr. Shankar was awarded the Padmashree by the Government of India in 2011. Sir, I, on behalf of the entire Civilianz family, welcome you to Civilianz Maze 2.0. I hope this session will be fruitful for all the participants present here. Over to you, sir.
Thank you very much for the glorious words of introduction. My colleagues, Sri Anurag and Santhya, told me about this opportunity and gladly accepted the opportunity because I could talk to civilians during this stressful period. The world is going through a very stressful period, and this is a time, I've been working in disaster management sector for the last 30 years across the world, and let me tell you this, every disaster actually gives you opportunity. This is an opportunity. COVID times actually gives you an opportunity to relook at your priorities, relook at the career opportunities, have a relook at yourself, look at ways to come out of this period. I believe that these sessions are actually being organized in connection with the Engineers Day celebration. And, engineers, every one of us, not only civil engineers, those who are in the faculty, engineering faculty, we have a very important role to play in this world because we make the world, especially civil engineers are responsible for the built up the environment. When I say built-up environment, I should say that civil engineers are primarily responsible for making the built-up environment. I mean, by way of bridges, by way of constructing the infrastructure facilities, roads, dams, etc., plus the shelter, the buildings, and the rest of it. So we have a very, very important role to play. This message should be actually underlined, should be understood by the participants in general, because we, first of all, as a class of civil engineers and architects, we should be very proud to say that you are a civil engineer because you are responsible for the built-up work. It's a very, very important thing to start. We have very limited time. Probably I'll talk for, that's what I told Arya. I'll talk for 45 minutes. We'll have at least 10 to 15 minutes of interaction. We'll have to wind up the session by 3 o'clock and we will start it. Now, I want, obviously I'm going to talk first, but I want the participants to react to me. You know, I will put forth my ideas, my thesis, as I would say, and you put your antithesis. You know, this is a conversation. Don't feel shy to ask me questions, because there is very definite chances that I will learn from you. You know, it should be very meaningful kind of a conversation where I will put forth the idea. You either absorb it or reject it outright. Let us get into a conversation. Only these conversations will take the process forward. You know? Don't limit it to just a talk. If I can give you some food for thought, some confidence at the end of the day, and some new insights, I'll be very, very glad and I'll feel very gratified. You know? I know it's a very limited audience, very limited opportunity, but each of these opportunities actually can open up many doors. If someone goes through the doors, me as a very senior professional will feel very happy, very contented, and I would, actually mark today as one of the fruitful days in my life. Today, I'm actually going to talk about sustainable construction, sustainable design, and basically about sustainable technology. Before we start any contemplation, any dialogue, any conversation on this subject, clearly, somebody will have to unmute. The moderator, kindly see that you unmute the others, because it's beginning to disturb me. Now, when you talk about any subject, you should ask these questions. This was a very important lesson that my mentor and my guru, Dr. Laurie Baker, told me. Before you design anything, you should ask the question whether this is necessary. If it's not necessary, let us not do it. Great message that I actually learned from Dr. Laurie Baker many, many years back. Whenever you hear somebody do something in the civil engineering sector, there are 3 questions that you should answer. Why? Why is he talking about sustainable construction and sustainable technology and sustainable? Why is the first question? What is the next phase of question part? And the third part will be what? Third part will be how are you going to do it? So why, what, and how are going to be the critical components in our journey. Let us go for a journey together. And I hope within whatever time that is there for me, I will try to do justice to that time by probably harping on my experience. I've been active in this field for the last 30 years. I've been doing only, as you know, by qualification, I am an architect, but the journey as an architect has taken me to amazing journeys in civil engineering. In Kerala, smaller places like Kerala, there is no really distinction between the architect and the engineer as far as the residential building sector. You know, as civil engineer, you're supposed to design, you're supposed to look at the structural design. You know, the basic design of the building can be done by you. Basic estimate, rest of it, you know, the construction management. We'll have to do it because normal people in Kerala can't really distinguish between architect and engineer. And as a practicing engineer, you're supposed to know about a bit of architecture and design and rest of it. Now, let me come to the point. Why are we talking about sustainable technology? For very, very a clear reason. Kerala went through heavy floods in 2018 and 2009. Everybody is attributing all these floods to some external reason. External reasons, like, you know, opening of the dams, you know, the rains that, you know, that lashed our state continuously, maximum amount of rainfall falling in a day. But the primary reason for all these disasters is the vagaries of climate change. So let us come to a point where climate change is probably responsible for every negative thing that is happening in the world, especially in the form of disaster. Now, coming to the point again, I said climate change is the primary reason for disaster. And who is responsible for the climate change? We, primarily we, civil engineers and architects, are primarily responsible for the climate change. You know, it's a very brutal statement. It's a harsh statement. But the truth reminds that we are primarily responsible for the climate change. I will qualify that a little. I'm sure participants listening to me are really perplexed, confused when I make such a brutal statement. But let me tell you, engineers being responsible, especially civil engineers who are being responsible for independent life, we should take the moral responsibility of climate change. Why? Because the most unsustainable activities that are happening in the building sector in the way of promotion of wrong materials and technologies, that is actually ripping the world apart. I will give you a few examples for that and talk about both pre-construction and post-construction scenario in India. We have limited energy sources in this country. We are looking at alternate sources by way of looking at solar fixtures, wind, etc. We are looking at alternate sources of energy because the hydroelectric energy that we get is going to be very limited in the days to come. The dams itself is a kind of a foregone development strategy. I believe, as an environment activist, I believe dams are not really an eco-sensitive intervention. We don't want to get into a discussion like that. But let us face this. 32% of the energy produced in this country, let me come back to that figure again. 32% of the total energy produced in this country is being used in the building sector, both in the pre-construction phase and post-construction phase. Just look at it. 32% of the total energy produced. We need energy for every damn thing. We want energy to move this country forward. And 32%, that's a staggering percentage, goes for building our houses. Then people will ask me, how do you qualify that statement? How do you really substantiate that statement? Let me tell you this. Materials and technologies that we use, the design strategies that we use are not necessarily energy efficient. That is why all my life, I've been actually talking against the use of cement and steel, at least in the domestic residential sector. I know cement doesn't have many alternatives by way of engineering properties, but this is time to optimize the use of cement in construction act. How do you use it is something that we'll discuss a little later. But why I am talking in cement and steel is because of just one reason. The production processes of cement is not at all energy efficient. We are still using technologies which are redundant, outdated, and that eats away a lot of energy. You go to any cement plant, you will see that the process of manufacturing cement, all the processes are kind of outdated and eats away a lot of energy. That is one reason I'm going to talk against cement. I know cement has such amazing, wonderful properties as a binder, strength giver, and things like that. But look at the energy that it's eating it. The same case goes for steel. We don't have many for taking tension. We don't have many alternatives. This is the only metal material probably that we have. But the production process of steel again takes up a lot of energy. We need energy to survive. We need energy to run this country forward. So both ways, you have to look at energy efficiency. Let me come back to the old statistic. 32% of the total energy produced in this country goes the pre-construction and post-construction. Second thing, we are actually beware. When I was much younger, probably at your age, I've seen a water-rich Kerala. All the 44 rivers in the state, I still remember, we talk about Nila, Periyar, Pamba, etc., in a very romantic way. But let me tell you this. Such a water-rich state is very soon going to be water-starved. The English poet who said, water, water everywhere, but not a drop to drink, is going to be harsh reality. All the rivers, I know this is a very brutal statement, but this brutal statement wake you up. Why this fellow is talking about sustainable construction, sustainable design all the time. All the 44 rivers in this country, all the 44 rivers in this particular county, I would say, in the country state, are certainly on a deathbed. Every river that you know, I'm not talking about Bharatapuzha or Pamba or Periyar, every damn river in this state are actually on a deathbed. Water is going to be a huge resource in the future to come. Let me go back to the statement that I made. Water everywhere, but not a drought thing. Is the state situation, region-specific issue. What is happening to the usage of water in domestic front? When, youngsters, you will remember, when they were opening the treasure gates of Sri Padmashree temple, the first day they probably discovered gold ornaments, diamonds, treasures worth around 1 crore. Third day, they were talking about 10 crores. 1 week after, they were talking about 100 crores. 15 days after, they were talking about 10,000 crores. 1 month after, they started talking about 1 lakh crores. As a senior architect, senior engineer, let me tell you this. I can comprehend that figure. 1 lakh crore is a figure that goes beyond your comprehension. You have to stop for a minute, look at your mental faculties, and try to comprehend the figure. I'm very good at mathematics, but even then, these figures continue to baffle me. At the national level, in the building sector, what is happening? I'll make a stop it at that. 5 billion liters. You know how much is a billion? Is it 1,000 million makes a billion. 5 billion liters a day. 5 billion liters a day is being wasted in our toilet to flush out the dirt from the toilet. 5 billion liters a day is being used in our toilet in the country to flush out the dirt from the toilet. 5 billion liters is a lot of water. And we are talking about a situation where water everywhere, but not everywhere. Likewise, when you look at the wood harvest, wood is extremely important. Trees are extremely important. ഞങ്ങൾ എപ്പോഴും ഒരു പ്രാർത്ഥന പോലെ നിലവിളി പോലെ പറയും മരം മാത്രമാണ് മറുപടി. Trees are essential for the eco cover, eco sensitivity. We can't cut down trees because they are a big shield, big cover. They actually talk about, combating. They talk about resisting the climate change by way of replenishing the ozone layer, by giving a shelter over the earth and things like that. These are absolutely necessary for our survival, our existence. 32%, again, the same percentage. 32% of the wood harvest that is happening in India goes for making the windows and doors, the residential building sector. Let me come back to that figure again. 32% of the total wood harvest in the country actually happens in the residential building sector. All these figures actually add up to make the situation almost unbearable for us. This is why, for the very same reason, we have to, can we just look at it and say that probably our children will suffer, we'll just pass this world? No. You, in your lifetime, we are going, me and my generation will be going in a few years. You are going to inherit here. And as it is, you are going to go. You are going to suffer and your children are going to suffer. If this continuous kind of violations are going to happen, manipulations are going to happen, we have to be right. So, this is why. Let me come back to the first statement that we, the civil engineering fraternity, as being primarily responsible for climate change, there is no other way for us but to going for sustainable construction practices by way of architectural design, sustainable architecture, sustainable material selection, sustainable technologies. Basically, look at sustainability as a building environment. There is no other way. No other way to survive. So, this is the primary reason why we need sustainable building resources to build our house. Now, what is it all about? What is sustainable construction? What is it? I've just put in a few words. Try to internalize the meaning of it. One is we have to optimize. We have to minimize and optimize. What do you mean by optimize? If you need 5 bags of cement for a particular plastering a wall, for instance, plastering a wall, or 5 bags of cement to build probably 2 walls in your house, can we take 1 bag out of it? That is optimization. Can we save some sand? Can we save some cement? Can we save some basic natural resources that come to us without cost? Can we do that? By optimizing, we can save a lot of things. And then we are beginning to talk the same language of sustainability. Sustainability is basically about 3 things. One of the major things is to reduce. Reduction is the key word. Is to reduce. I'll come to the rest of it later. You have to reduce. We have to reduce the consumption. When you get a disease, if you are sick, First thing doctor will tell you is to go for a kind of a diet, which is very necessary. Even during COVID times, we are talking about a very strict diet that will probably add to your immunity. So likewise, we have to take a call on this. How to optimize is something that we will see later. World, the earth has very limited resource base. I mean, in India, we have talked about a huge resource base in terms of materials and technology and even the human capital. I believe that we are best, especially Kerala, I'm talking about Kerala, the human resource base in the form of carpenters, masons, building technology, we are the best in the world. I work across the world. I work in almost all the states in India. And I should say this with conviction that our labor skills are probably one of the best. So we have the resources to do it. We have the traditional knowledge to do it. You see, the change of vocabulary of building materials, something which is really, really fascinating. Earlier, in Kerala, we used to have a lot of wooden houses. But once wood actually became an extremely expensive commodity, we started to move away from it. That's what happened the world over. Once you find a material suddenly becomes unsustainable, then we move away from it. But how do you make even wood sustainable? The thing that we will probably deal in the next session. For everything, we talk about optimization, we have to talk about reducing the consumption, and then looking at reusing some of things is very important. So basically, the strategy that I'm proposing for the sustainable construction is first to reduce. Obviously, when you reduce even the footprint, the plinth area of a building, actually you're talking about sustainable. COVID times especially are very stressful times, where we discover the beauty of smaller houses, which we can clean by ourselves. The servant-made based economy is all going. We have to depend on our own resources. Smaller the better. Schumacher, who once said, "Smaller is beautiful," is coming back to our mainframe code. So we have to look at it, optimize, reduce, reuse. Reuse is very important. A lot of buildings, especially in Kerala, I've been working for the last 30 years, 3 decades. I should tell you this, because I'll miss this point later. A lot of buildings are being taken down by saying that buildings are not safe, buildings don't have life. They call a 30-year-old building, 30 years as an old building. My father built this old building. I will ask, when I ask these questions, they said, my father built it 30 years. I said, stupid. How can you say that this is 30 years old? Tell them that this is 30 years young. 30 years യൗവനം ചെറുപ്പക്കാരൻ ഏറ്റവും ചെറിയ കാലയളവ്. 30 years nothing in the life cycle of a building. You would call it young, don't call it old. It's a very important strategy. നമ്മുടെ പ്രായമുള്ള അച്ഛനമ്മമാരെ നമ്മൾ പ്രായം പറഞ്ഞിട്ട് നമ്മൾ കുരുതി കൊടുക്കാറില്ല. Other old buildings are very solid engineering bases. Only the contemporary times, the contemporary needs that we have, lifestyle changes. Actually, are talking about probably a different paradigm spaces, but you can actually save, retrofit. Retrofit is a very important word now in our vocabulary. By making some cosmetic surgeries, bringing a wall down, probably make a new window, you can get more light, ventilation, more area, and retrofitting is something that we have to integrate mainstream back to mainstream. And that will mean a reduction of a lot of conservation effort, reduction of material, and like that. So this is what sustainable architecture is all about. The technologies and materials that pertain to time, to the context, social context, cultural context, who actually talks about relative strength, relative life, etc., etc. It actually touches the social fabric of Kerala, social fabric of India. And that is what sustainability is all about. Basic mantra is always use local resources, local materials, local technology, local capability. Three very important. Local materials, local should be the mantra. Local materials, local technology, local architecture, local lifestyle, and very important social context in this. Very important. That's what makes sustainability very tricky. Now, I'll very briefly go to some of the technologies, technologies and techniques. I can expand it further because another 12 to 15 minutes I have to wind up the session and start we should start the conversation. So just to wake you up, I will actually talk about some very provocative tips by introducing some of the materials that I've been using for the last 30 years and asking you why I'm mainstreaming. Let us look at three materials and three technologies that I use. For me, not only for me, for everyone, there is a parameter indicator list which will help you select materials. I'll tell you about my list of parameters. You can add, you can delete. It's me. It's my personal list of indicators that I use for selection of materials. What are them? One obviously is the durability and the life of the building. Everything that can contribute to the durability and life of the building is very, very critical determinant for a normal Malayalam. You don't want your building to come down in 10, 15, 20 years. No. You want it for the ordinary building to last for two lifetimes, isn't it? Yeah. You can't compromise on this time and the durability and life of the building. That becomes the first. But to me, I add certain more criteria. What are the cost efficiency? Very important. Very important because we are running out of resources. We need a lot more cost efficient building. And the technologies and the materials that it use should actually talk about cost efficiency. Much meaning. That will be very important criteria for me to select materials technology. Cost efficient. I build only low cost houses. I build only cost effective houses. And for me, the choice is very limited. I take only materials that are cost efficient. Earlier, when I was your age, I still remember, there was this old research facility, central government research facility for building materials, which are actually trying to produce, put into market, a new material called coconut pith. Taking coconut pith as the infill, they were trying to make new bricks. Very good, dimension, very stable, very lightweight bricks, very beautiful to look at. The dimension stability with a uniform color, uniform texture. It's a delight to see such a material with such a metric dimension. But and using a waste material as easy. But it couldn't be promoted just because of one thing. And the ordinary brick was costing 1 rupee. This was costing around 7 rupees. So what do you say about the technology content, the beauty of the building, the beauty of the material? There's no way out. We want to promote a technology, especially in the third world, especially in the domain that I'm working at, the residential sector. You have to look in for cost efficient. Cost efficient is an important parameter. What is the third parameter for me? Is obviously it has to be eco-sensitive material. I say this with some guilt because the first 20 years of my career, I've been predominantly using burn bricks. After 20 years, some of the slides that you saw about my own creation, construction, they're all exposed brickwork. But later, I found out brick is not a very exposed material. We're destroying the mother earth. We are actually destroying the mother earth, the profile, etc., manipulating that, taking out a very precious thing and baking it. Baking itself is not energy efficient. We are cutting down a lot of trees, coconut trees, to burn these bricks, kata bricks that we make, burn it. The entire process actually talks about very bad eco-sensitivity, very bad energy emission, thereby making burn brick a very unsustainable building. I moved away from bricks probably last 10 to 12 years. I basically, most of the buildings that I built are all earth buildings. So what I want to tell you is this: cost efficiency, energy efficiency, and eco-sensitivity become very, very important part indicator for me. One of the things that you don't use, but I use all the time, is look at insulation. The technologies that I use, I take it as an additional advantage to have insulating quality. Why should you talk about insulation? Temperature rise is the reality now. Each year, temperature is climbing up. We never had such harsh summers anytime in my life. And it's 2:38 now, I'm looking at the watch. And it's time to look back and realize the fact and go ahead. I mean, I'll just stop it at these parameters of selection of technology. I'll come to actual technologies per se and actual materials. For instance, I've been talking about earth as a building material for a long time. 20 years, I've been talking about mainstreaming earth as a very possible buildable material. What gives me the confidence? Two reasons. I myself is a mason. I myself can work with my hand. When you feel mud, when you touch mud, when you feel mud, suddenly you actually discover properties of mud. This is a very critical element that is civil engineering. You don't get hands-on experience unless you get hands-on experience. If you don't touch earth, you won't be able to talk about earth as a sustainable building. You have to touch it. You have to feel it. Once you feel it, the experiential part will come up. So that is why I take a great pride. I feel very happy when I talk about mud because it's close to my heart. I'm very sure of the engineering property, the bearing capacity, the rest of the strength, durability, cost efficiency, insulation, energy efficiency, and the eco-sensitivity. In everything, mud actually qualifies. And that is why I've been talking about mud blocks. And people out there, earth is always taken as a poor man's building material. Poor man's building material is usually kacha, right? But can be very interestingly used in four ways. You know about only one way. You have seen these kacha bricks in the rural areas with which you used to build buildings with thatch roof and things like that. Over the years, technology has been upgraded. Now we are talking about stabilizing the mother earth with some very useful stabilizers. And can you unmute? Somebody is on the line. Can you unmute, please? Can you mute yourself? And then we are talking about mud as a very viable building material. It's insulating, it's cost efficient, it is durable, it's strong. What is the unit of strength when you talk about civil engineering? You talk about compressive strength. Any material actually gets qualified by the compressive strength. What is the compressive strength that we normally require for a residential building of a material? When you talk about ordinary country burn bricks, what is the unit of measurement? What is the compressive strength that you get? To me, the normal brick that you get in the market, I'm not talking about wire cut bricks, ordinary country burn bricks can give you a compressive strength of anything between 20 to 25 kilograms per centimeter square. 25 kilograms per centimeter square is probably the best that you can ask for. Country burn brick. When you upgrade mud, a stabilized mud block. Let me say it with such conviction and such confidence that it gives a compressive strength of more than 35 to 40 kilograms per centimeter square. Ordinary country burn gives you 25 kilos, hardly 25 kilograms per centimeter square of compressive strength. When you go to stabilized mud block, it talks about 35 to 40 kilograms per centimeter. Very, very high standard of stability, strength, etc. So this is why I had been extolling the properties of earth, not only as a walling material, but as a foundation material. In my house, I don't know whether it's shown on the screen, my roof is made of mud. For the first time. There's no reinforcement over that. There's nothing over that. Pure mud. So mud as a foundation material, mud as a walling material, and mud as a roofing material. So what qualifies mud? Basically, it's a no-cost material, isn't it? No-cost material because you can get it from your parambum, മുറ്റത്തു നിന്നൊക്കെ നമുക്ക് എടുക്കാവുന്ന മണ്ണാണ്. Even if you bring mud from outside, it won't cost you a fortune. Very, very cheap. Now, people will ask me, how much mud will you require for building a 600 square feet house? 600 square feet house? Let me tell you, very little mud. 1 foot of mud from a 6 cents of land. 6 cents is, how many square feet and square meters. 6 cents of land, 1 foot of mud will give you enough mud to build a 600 square feet of building. I have put the largest of the world, talking about measuring around 600,000 square feet. That's the confidence by which I'm exposing the use of mud. Mud, earth is as strong as any other walling material. I'm telling you, when you upgrade it to the engineering standards, now it is beginning to appear in the engineering manuals, the very precious stuff. The quality of mud is being upgraded, is being validated. So very soon, mud will become earth blocks will become new futuristic building material. And that technology using, earth blocks actually will become newest technology also. What is happening with the technology part? When I say earth block, when you build up this interlocking mud block, what is the typical savings that you make in terms of sand and cement? You waste a lot of sand and cement for making this model. When you build your wall with stabilized mud blocks, you don't need it because it interlocks itself. And there'll be precious savings in terms of cement and the sand that comes. Sand is a very precious commodity now. All the rivers are becoming these kind of shallow rivers because of illegal sand mining. So we have to find alternate ways to save, conserve sand, very basically material. Second material that I will store, I will actually talk about it with us by bamboo. Why bamboo? Because bamboo has a very definitive, comparable tensile strength. Why do we steel in concrete? There's no tensile properties. What is tensile strength parts into the concrete? The same reason, some qualities of bamboo. Everything you have to select. There's a selection process. Judicious selection should be there. Some varieties of bamboo can take a lot of stresses, a lot of tension, and this can replace the tensile reinforcement that can be. Bamboo has got such wonderful properties. I don't want to dwell at length. They can be used piling material, foundation, walling, roofing, etc., etc. I'm also specializing on the concept. Someday soon, probably after COVID times, we'll get time to look at bamboo initiatives, bamboo building, bamboo building, bamboo building. Trying to do all the last. Now coming to third material, lime. Kerala is a lime state. You have to go to the richest lime deposit in the world. We have got the richest lime deposit in the world. And lime is as good as cement. For the cementitious properties, lime is as good as cement, except in certain applications, engineering applications. 15 feet thick lime deposit in the depths of Maybanat Kayan is a precious resource that we have. We don't use it. When I was much younger, or your age, I used to see, I'm from a Shastra Sahitya Parishad activist. When I was in school, I used to go to Kumaragam, sell the books, sell smokeless chulas and all. There's a lot of people working in the lime sector, poor people taking the lime from the riverbed, taking it to the shore. The ladies, chakila, lime arecheduka. There was this Kadavandis that actually took the lime to the market, sell it in the domestic market. Lot of employment opportunities, lot of potential for rural economics. Lime is as strong as cement. In fact, some of the engineering properties in lime, like the floor concrete. Lime concrete is anything better than cement concrete. But lime has got a limitation like cement. It has got structural limitations. It can't be used for concrete chemical reactivities. So I talked about lime, cement, lime, mud, and bamboo. The same way, 240. Same way, we can use technology. I'll just talk about one or two technologies that are widely. We talk about rat trap board, brick masonry. We talk about that. What is the rat trap board? 25-30% in bricks. Great saving. In terms of mortar, we need lesser surface area for putting this mortar. That actually comes to by 50%. There's a lot of saving in cement and sand. Bit of saving, 25% saving in number of bricks, 25 to 30% saving in sand and cement because we save a lot of mortar. It is a cost efficient, energy efficient, and it gives you an additional this thing because when we have this rat trap board building, you get an insulation space in between, a cavity in between, which insulates. In countries like India and places like Kerala, we need insulating walls which can very effectively resist the onslaught of cold and heat, So this is a bonus that we get. We talk about cost efficiency, we talk about energy efficiency, we talk about resource efficiency. These things, same thing, we get a lot of insulation there. Likewise, my friends will actually tell you about that. Anthea and Anida will tell more about it. Also, we use a lot of, new technologies for cement concrete, RCC work. We use filler slab. We actually, I don't want to go into the engineering details, probably they will explain it better. There's an imaginary neutral axis. Below that, tension. Above that, compression. Above that, tension, and below that. So the compression zone is basically strengthened by concrete components. The tension zone actually gets tension is being taken by steel, which is kept on the lower part. And we really don't require cement concrete below the neutral axis, but we need a shield to protect the steel rods that come below the neutral axis. How do you protect? By having a protection, because steel will get rusted if it's exposed to atmospheric air, and iron oxide can get formed on the field. So needed atmospheric shield. That is why we use a lot of concrete in the lower half. We can take out excess concrete, replace it some waste material. It can be broken tiles, it can be coconut shells, it can be thermocol sheets. Any damn thing can go in as a pillar. When you do that, the sulfate of the slab comes down. The reinforcement amount comes down. Because the basic component of calculating the steel requirement for this comes by way of sulfate of the slab. Do you know the sulfate of a concrete cube? 1 meter by 1 meter by 1 meter? My dear friends, it is 2,400 kilos. It's a lot of weight, 2,400 kilos. With the weight of probably 40 adults standing together, it's a lot of weight. 1 meter by 1 meter by 1 meter, this thing weighs around 2,400 kilos. So, what I want to tell you is that concrete filler slab, walling, mud, earth blocks, bamboo is a tensile material. These are very local solutions, technology solutions to take the sustainability message forward. By doing that, by having very simple interventions in engineering, especially in the residential construction, we can actually save the world. We can look at thwarting the challenges that the unsustainable usage of materials and technology, architecture, by having our own local context, social answers, and very relevant sustainable answers to face this challenge. I'm sure I'm going overboard. It's already 2:52, but I want to leave some questions unanswered. I don't want to I want you to dwell on this further. I should leave some open-ended questions because this is my life, this is my blood, and this is my tears. Sustainable technology is a part of my life. That is why I say it with compassion and passion that we need sustainable construction. And we don't have a choice. We have gone out of choice. We have to look at sustainability. We have to look at greenness. We have to look at green technology. We have to look at materials. Because we have already lost chances, And this is exactly question me about that. Why I have life mission, why Habitat came out of that mission is something of can be of some interest. We thought socially it is not correct. Politically it is not correct to grow in for pre-engineered structures for very, very low cost building. Because pre-engineered structures talks only about cement. It talks about reducing the labor opportunities, but increasing the use of cement and steel in a very, 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 very big way. It is not to, professionals like me. That is why we opted out of that. We can't go for, these kind of technology marvel. I know it's a technology marvel. I accept that. Probably for, much bigger buildings than the, but it is very important that we take our own decisions at local level. Because I still believe that local is going to be the mantra. It was Mahatma Gandhi. I'm greatly influenced by Mahatma Gandhi, the father of the nation, who said, whenever you want to build a sustainable building, he didn't use sustainable, but he was always insistent that he was talking about, Swarajya concept. You have to source the materials from a 5 kilometer radius from the place we are going to build. He talked about local availability. He talked about usage of local technology. He talked about use of local capability. He talked about local social climate. He talked about, culturally appropriate, which I think is in need of our earlier buildings. We don't have to go back to the traditions for, that is romantic notion. But let me tell you, all our old buildings, very sustainable. There are a lot of sustainability ingrained into that. That's why നമ്മുടെ അപ്പൂപ്പൻ്റെ അമ്മൂടെ വീട്ടിൽ പോകുമ്പോഴത്തേക്ക് ഒരുപാട് അസൗകര്യങ്ങൾ കാണാം. പക്ഷെ ഇതെന്നും തണുപ്പ് തന്നത് നമുക്ക് എപ്പോഴും അഭയം തന്നത്. These are the kind of sustainability concerns that we take forward, and I think we should stop at that because there's only 5 to 6 minutes left for the completion of the Civilianz. Thank you very much for the opportunity given. Participants, thank you very much for listening to me with that attention. Nice muted. Anyway, thank you very much. Once again, my colleagues out there, Sandhya and Anurag, for opening this venue for me. It was sheer pleasure and happiness for me to share my ideas with you. This is just the start of a conversation, and I hope in the days to come, plenty more opportunities. And I expect a few of you to kindly ask me questions. Arya, if you're out there, Arya, I mean, I don't know. I think
Yes,
she's
sir.
the person who,
Yes,
person
sir.
who is moderating.
Yes.
Can you take a few questions from the participants and quickly convey to me?
Yes, sir. Yes, sir. Sure. Like participants can unmute now and ask. There is an option. You can unmute yourself and ask.
Or put it in the chat box.
Yeah.
മലയാളത്തിൽ ചോദിക്കാം. മലയാളത്തിൽ ചോദിക്കാം. മലയാളത്തിൽ ചോദിക്കാം.
മണ്ണ് വീടുണ്ടാക്കിയിട്ട് മണ്ണിന്റെ
എനിക്ക് കേൾക്കാൻ കഴിയുന്നില്ല.
Jasmine, was that a question?
പറയാം.
Jasmine?
Arya, can you
No, it was by mistake. It was by mistake. No. Okay. Thank you, sir. Thank you.
Sir, we had a registration form for this event. So we had asked them if they want to ask any question or not in that registration form. So I got a question from that. It's how can we maintain the durability of sustainable structures, especially which is made up of clay and bamboo? Like we have.
I'll quickly answer that. Quickly answer that before going to the next question. This is the question that everybody is asking: durability life. I told you first criterion for selecting any material, sustainable material, is strength and its durability. Because we don't build it for a limited period of time. We want these buildings to remain for at least 2 lifetimes. although there's a physical life to every building material, that we still would like our buildings to be there for a long time. And so when I talk about mud, when I talk about sustainable materials, I'm very convinced. I'm very convinced about the durability and the strength of materials. I'm very convinced about the engineering property. You know, we are getting these integrated in the structural manuals. You know, you have the Central Building Research Institute actually certifies the strength of the materials. I think we have the Structural Engineering Research Institute in Chennai, which certifies that. We have Indian Science in Bangalore, which certifies that. So you know, this is something that we should understand. When I talk about sustainable materials, I'm talking about long life materials. I'm talking about durable materials. Engineeringly, when you look at engineering parameters, validated materials, things like that. So that is it.
Okay.
Question. Yeah. Please feel free to ask question. Write it down. മലയാളത്തിൽ എന്തെങ്കിലും ചോദിച്ചാൽ മതി. ഇല്ലെങ്കിൽ എനിക്ക് വിഷമമാണ്, കാരണം ഞാൻ സംസാരിക്കുകയും നിങ്ങൾക്ക് മനസ്സിലാകുകയും ചെയ്തില്ലെങ്കിൽ വാട്ട് ഇസ് യൂസ് ഓഫ് wasting my power.
There is one question in the chat box. Green insulation is one of the sustainable construction. It is an energy reducing one. Can you explain how it reduces the energy in construction? Asked by Anjana.
Yeah, Anjana, I was talking about energy reduction. It's very, why I talked about energy is needed for sustenance of the world, planet. But when you look at, I'll just tell you a very small example how energy is being spent in making the country burn brick. Local materials that we all processing. When you talk about processing, there's a lot of mechanical energy that goes into that. When it actually goes into burning of brick kilns, there's a lot of energy. I mean, the vertical kilns that we propose now for making use a lot of electrical energy. When you talk about burning it, we are cutting down trees and we are burning it. Burning is actually burning away of energy. That you should understand. Burning is burning away of energy. That is why we have to look at the process by which we could save energy. That's why I told you in the beginning that I trying to optimize the use of steel and cement for the same reason. The production process is highly energy intensive. Burning is highly energy intensive. We have to move away from the intensive process and get to efficient, optimal process of production. Very critical. We don't see it, but we have to internalize the usage of energy at that point. This is why. But look at a compressor. There's no process. There's no process. You take mud, you put it into a machine. The only process is a human intervention whereby you compress the material. By compressing the material, you gain the strength. So these are very simple technologies. It actually talks about energy efficiency, cost efficiency, and the rest. Yeah. Any other question? We don't have more questions. I mean, please allow me to wind up here because it's 2 o'clock. And
yes.
Arya, what do you say? Can we wind up?
Yes, sir. I think there are no more questions.
Hello.
Yes, sir. There is someone.
Hello, sir.
Yes.
Sir, ഇപ്പോൾ നാച്ചുറൽ ആയിട്ടുള്ള ബിൽഡിംഗ് മെറ്റീരിയൽസ് ആയ മഡ്, ബാംബു, ലൈം ഇതൊക്കെ ഉപയോഗിച്ച് നമ്മൾ കൺസ്ട്രക്ഷൻ ചെയ്യുകയാണെങ്കിൽ കേരളത്തിന്റെ സാഹചര്യം അനുസരിച്ച് മഴയും അതൊക്കെ റിപ്പീറ്റഡ് ആയിട്ട് വരികയാണല്ലോ. അപ്പൊ ഇത് നമ്മൾ എക്സ്റ്റീരിയറിൽ ഉപയോഗിക്കുകയാണെങ്കിൽ ഉണ്ടാകുന്ന പ്രശ്നങ്ങൾ എങ്ങനെ നമുക്ക് അവോയ്ഡ് ചെയ്യാൻ പറ്റും?
ഈ മണ്ണിന് ഈ പ്രഖ്യാപിത ശത്രുക്കളുണ്ട്. ഒന്ന് ചെതലും ഒന്ന് ഈർപ്പവുമാണ്. അതിന് എങ്ങനെ നേരിടാം എന്നുള്ളതിനെ പറ്റി ഞാനൊരു ക്ലാസ് എടുക്കാം. പിന്നീട് എപ്പോഴെങ്കിലും ആര്യ അവസരത്തിരിക്കണ ഒരു ക്ലാസ് എടുക്കാം. പക്ഷേ ഇറ്റ് വെരി ഇൻട്രസ്റ്റിംഗ്. നമുക്ക് ടെക്നോളജി കോൾ നോൺ എറോഡബിൾ മഡ് പ്ലാസ്റ്റർ. നമ്മുടെ CBRI വാലിഡേറ്റ് ചെയ്ത ടെക്നോളജിയാണ് നോൺ ഇറോഡബിൾ മഡ് പ്ലാസ്റ്റർ. മോൻ ചെന്ന് കമ്പ്യൂട്ടറിൽ ചെന്ന് നോക്കണം. നോക്കുമ്പോൾ നമുക്ക് മനസ്സിലാവുന്ന കാര്യം വെച്ചാൽ ഇറ്റ് ആക്ച്വലി ഇറ്റ് റെസിസ്റ്റ് മോയ്സ്ചർ ഫ്രം ഗെറ്റിംഗ് ഇറ്റ്. If mud gets moisture, it would melt. നമ്മുടെ ചോക്ലേറ്റ് അരിയുന്ന പോലെ അരിയും. There are several methods with it could overcome that. Very traditional methods by which നമ്മുടെ കംപ്രസ് ചെയ്യുമ്പോൾ തന്നെ മണ്ണ് കംപ്രസ് ചെയ്യുമ്പോൾ തന്നെ actually can resist a lot of moisture for coming in. And seeing is believing. I know seeing is believing. When I say this, you will not understand it, you will not feel it. But sometimes when you see big buildings made out of, my own office building is a storage building. Compare someday to look at how stabilized mud blocks are being used for very, very, very tall vertical surfaces, which gets all the rain all the time. It really gets wet when it rains, lash over that. And seeing is believing, Beauty of a cake is in eating. Seeing is believing. Sometimes look at it. It's nice that you question it at this age.
Okay, sir, there is one more question in the chat box. Using mud and bamboo and reducing concrete content, is it possible to build more than 2-story buildings?
Of course. I mean, I made a statement at the beginning that I built a 600,000 square feet mud building in the world, which is the largest mud building in the contemporary world. I did it in Bangladesh, Roipara, under the very strict surveillance of the Civil Engineering Department of Dhaka Engineering College. Every stage was validated and certified. I'm telling you, you have to use it judiciously. What happens? What happens if the structure goes not 2-story, 3-story? You can use the way you want mud and bamboo, but when it goes beyond 3 stories, obviously the structural system will change. You'll probably talk about a column and beam structure. You have to brace it up properly. You'll probably use columns for, but infill walls can be all mud and bamboo and things like that. So, I mean, I'm not passionately talking about mud as a modeling material for a multi-story building. Yes, it can be a basic modeling material even for multi-story building. I will tell you one building which you won't believe. There is this emergency control, some facility in Kerala Bhattacharya. It's a 14-story building, opposite the civil services petrol bunk is there. Just opposite that, you can see that in Vellayampalam, next to the state disaster management authority, right inside the campus, there's a 14-story building. All the outer walls are all mud bricks, stabilized mud bricks, 14 stories. But they have put some color over that, and that's why you're not seeing that. It's all ordinary stabilized mud blocks, 14 stories up. So, I mean, there can be structural implications, structural limitations, but you can use it the way you want. Thank you.
Okay, sir. Thank you. I think there are no more queries. So one more queries. Okay. Is eco-floating homes be implemented in Kerala's climate? What are the possibilities?
Eco-floating house, the new term for me. And if you are talking about floaters that Kuttanad people are proposing this, I don't think it's very sustainable. I mean, I'm telling you, people will term it eco-sensitive, but I don't think it's going to be eco-sensitive. But anything that produces water is not acceptable to me. You will put your sanitation into the water. That's what happening. And we have enough land to build our houses. We don't have to go into the water. I mean, if that is what you mean, even at my age, I'm not able to understand what you mean by floating houses. I've seen some floating houses. I've seen it all over the world, in Vietnam and all, where the density of population is very high. They have gone into the Mekong River, and you have townships, floating townships in the river. In Kerala, I've seen it only as tourist structures, and I have a feeling that probably floating houses may not have the kind of cost efficiency built into that. You have to take it together. Cost efficiency, energy efficiency, eco-sensitivity should come together to be meaningful. And I'm sorry for the very abstract answer. Thank you very much.
Okay, sir. Thank you. So thank you so much, sir, for providing us with your valuable insights on sustainable building construction. And I still remember back in 2016, I have visited Habitat Technologies office and your house as well. It was under construction back then. As part of a training program, I have visited, and I was like awestruck with the ways of using natural lighting and the wind and all. I was really delighted to watch all those and the possibilities of using mud and bamboo and other natural materials for construction. Okay, I think we'll quickly wind up the session with a vote of thanks from our team member from Civilianz, our research and development wing advisor, Ms. Nimisha is here. Nimisha, please.
Hello, good afternoon. Good afternoon, sir. I deem it a great honor and privilege to propose the vote of thanks on this special occasion. First and foremost, on the behalf of Civilianz, I thank Sri G. Shankar sir, who despite his busy schedule has found time to grace this occasion and delivering a wonderful session on sustainable building construction. As the current scenario, buildings are responsible for a lot of the world's energy waste and overall energy use. Sustainable practices can help minimum waste, conserve energy, and even save our money, and need to be integrated into all construction endeavors for the future of the earth. As a civil engineer, I hope all the audience got much idea about the sustainable practices. Thank you so much, sir. And I thank all the team members who worked hard to ensure this success. Last but not the least, I thank all the participants for your cooperation in making this session a resounding success. Once again, thank you all. Thank you, sir. Thank you.
Yes, thank you, Nimisha. And thank you, sir, once again from my part. And thank you to all the participants who have been patiently in the webinar, and also for putting your queries and doubts in a very well-mannered way. Okay, so we are on the second day of Civilianz Maze 2.0. So we expect similar participation from your side in the upcoming days as well. Tomorrow we'll be having a webinar on career opportunities for civil engineer in the public sector. And also day after tomorrow, we'll be having the quizzing event. So if you haven't registered yet for the 15th, the Engineers Day program, please do that. Please do register, and certificates will be provided for the participants who have registered only, who have registered for all the webinar and quiz session. So if you haven't registered yet, please do. The links are provided in all our WhatsApp groups and all. So yeah, with this, we will wind up the session. A feedback form will be available to you in WhatsApp. Through WhatsApp, we will be sending you a feedback form. So please do fill that also, so that we can provide you certificates through that way as well. So keep in touch. Stay safe, everyone. Take care. And this is Arya.